So I first want you to look at the inside of your notes. We're just going to do a quick little review here. Remember, the way you decide how you are going to solve the problem is you look at where the vertex of the angle is. So in this first column, we have the vertex outside the circle. And we have this one right here where it is created by a tangent and a secant line. Here's with two secants. So they look different, but it doesn't matter because what matters is where the vertex is. We can also have it where it's created by two tangent lines, which we'll look at in just a minute as well. But it has to do with where the vertex is, and it's outside. You could have the vertex inside the circle, okay, and you still have two intercepted arcs in both cases. If the vertex is outside the circle, you subtract the two. If it's inside the circle, you add the two. And of course, central angles are a special case. We could use this rule, but that's kind of a waste of time, so it's up to you. Then if the vertex is on the circle, whether it's an inscribed angle or not, you only have one intercepted arc, so you can't add or subtract them, so the angle is just half the arc. Okay, does that make sense? We all good? Any questions? All right, so then let's go to the very front. Over here, well, why is this being weird? There we go. Okay, so we're going to look at this one. Now that 24 looks like it's just kind of floating out there, but this 24 refers to the angle right there, right? And we are looking for the value of x. So this is an angle where it is created by two tangent lines because it only intersects at, each line only intersects at one point, okay? And then we know from what we just discussed that if it's outside, then the angle is equal to half of something. And since I have two intercepted arcs and the vertex is outside, what do I do with them? Big minus small. Good. So I'm just going to put B minus S. All right. So in order for me to be able to substitute stuff in to solve, because in any of these cases, if you can just say that the angle is equal to half of the big arc minus the small arc. That is very unofficial notation, but you know where to substitute things in. The angle may be represented by a number, which in this case it is, it's 24. Or it may be a variable, it could be x, or it could be an expression and be 2x minus 7 or something like that. It doesn't matter. Whatever these things are, whether they're letters, numbers, whatever, you just substitute in what you have and you go from there. But you have to have something to represent each of those three pieces. So we have 24 to represent the angle. Do we have something to represent the big arc? Yes. What represents the big arc? X. Okay. Do we have something to represent the small arc? No. Okay, so we need something so that we can substitute it and actually solve for something here. What do you think maybe could represent the small arc? Huh? Okay, we could call it arc AD, but then that doesn't, I wouldn't be able to solve anything, right? Okay, 360 minus x, what do you think about that? We don't know what x is, but that's okay. Instead of doing something else like y or arc AD or anything like that, if I just substitute, if I put like a y there, then I have two variables. And sometimes you have to, right? Sometimes you have to and you're not going to get an actual numerical answer. But I'm going to. When you get this, how many arcs are intercepted? 2. Okay, so I have arc AD right here. And then I have this arc right here. So how much of the circle gets intercepted? All of it, right? And the green plus the pink together have to give you what? 360, okay? So if the whole circle gets intercepted, which it didn't in the other cases like this, but in this case it does. The whole circle gets intercepted, so together they're 360 degrees. I know the pink one is x, so just like An just said, the only thing that makes sense here is 360 minus x. So now you have something to represent each one of them. It's nice if you already have a variable. If you can do it in terms of that variable, then you have something that you can actually solve because you only have one variable there. Okay, does that make sense? All right, so I want you to take those three things, substitute them in, and work on getting x, and I'll give you a few minutes to get that done. Okay, so if weird things are happening for you, that's because you're making a very common mistake that you probably make a lot and will probably, if you don't even know what I'm talking about, still continue to haunt you in Algebra 2, and in pre-cal, and in calculus, and for the rest, and in physics, and everything else, and for the rest of your math career, and you have to learn to stop making the same mistakes over and over and over again. At some point, things have to start to improve and change. So, when we substitute this in, I get the measure of the angle, which is 24, is equal to half of the big arc, which is x, minus the small arc, which is 360 minus x. Okay? Then once you substitute it in, you have to do the algebra correctly. First of all, you have to substitute it in correctly, and then you have to be able to complete it correctly, which is basic algebra that you actually learned before Algebra 1. Okay? When you substitute something in that has more than one term, you have to use parentheses. Sometimes those parentheses are important, and sometimes they're not. Are they important here? Yes, they are hugely important, right? Because, first of all, I don't want to distribute that 1/2 anyway, so I'm going to multiply both sides by 2, and I'm going to get 48 over here. But then this is going to give me x minus 360, then what? Plus x. Okay? That cannot be a mistake that you keep doing over and over and over and over again, because for some of you, that happens every single time something like this comes up. And again, at some point, you have to start improving and not making those same mistakes. So then that gives me 48 equals 2x plus 360, I'm sorry, not plus, dang it, minus 360. And then that gives me 408 equals 2x. So what does x equal? 204. You also have to be able to recognize what it is you're struggling with, because what I have here in purple, that's the geometry. Okay, that's the geometry of it, is understanding what's going on, which process to use. This right here, coming up with that, that's algebra. It's actually pre-algebra. This is, and then substituting it in and completing it, it's all algebra. But it's, even though it's algebraic skills, it's not stuff you learned in Algebra 1. It's stuff you learned before Algebra 1 and have applied and reapplied and reapplied. And so 99% of the time, it's not the geometry you're struggling with. It's the basic math and the algebra. Okay? And again, those things have to start to improve. Okay? Questions about this? We good? All right, so if you haven't done so already, you can go ahead and glue that in, and then you have the rest of the class period to work on that.